So yesterday we already talked about the inverse trig functions. First we looked at their derivatives and refreshed our memories about those, right? Because we probably have not been, using them a lot. Well, no, we probably not. We have not been using them a lot, so we probably forgot them, right? Or had, kind of little brain farts with them, or whatever you want to say. Arctangent, like I told you, is like the most prominent one. We really need to make sure we have that one down. So the derivative of arctangent of x is 1 over the square, or 1 over just 1 plus x squared. The next most important one we should have down is arcsine, 1 over the square root of 1 minus x squared. And then lastly, we have the arcsecant, which is the one you see the least of all on the AP test, 1 over the absolute value of x times the square root of x squared minus 1. Okay? We take those derivatives, and then we kind of work backwards, and we result in these integrals. Okay? So here we notice du over a squared plus u squared, which is awfully close to this 1 over 1 plus x squared. Okay. The difference is that the number here doesn't have to be 1. It could be 4 or 9 or 16 if we had nice perfect squares. It could be any number here, really, plus then, and it doesn't have to be just x being squared here. We could have other functions. Okay, so here it's just 1 plus x squared. But here, really, to integrate this, it just needs to be a number and then like something with x squared there, and we can use that to then rewrite it in this way. So if we can rewrite our integral such that we have like 1 over a number squared plus a function squared, then it integrates to this. 1 over a, arctangent u over a plus c. Same thing with sine. 1 over the square root of a number squared minus a function squared, arcsine of u over a. Notice here, arcsine does not have the 1 over a. Okay, it doesn't have a coefficient there. It's just arcsine, plain. Okay, plus c. And then there's the arcsecant, the u square root of u squared minus a squared, that does have the 1 over a, arcsecant of absolute value of u over a plus c. Okay, so we did a basic one yesterday where we saw this square root of the quantity 4 minus x squared, and we were like, okay, which inverse trig did that kind of match to?
The one your finger's pointing to.
I'm pointing to this one. Which one does this match to?
Oh.
The arcsine, right? It kind of looks like arcsine. It's a number squared minus a function squared. The function is just x. So it's helpful to take this and rewrite it 4 as 2 squared, and then the x squared as x squared, right? This makes it kind of much more obvious here. Our a is 2, our u was x, so I let u equal x, so du is dx, and so I translated this in terms of u, and we could integrate this. So the integral, as was written here, okay, arcsine is u over a, so u over 2, arcsine of u over 2 plus c, and so we plug back in for the u, it's x over 2 plus c. Okay. Okay. So, yep. Oh, you're just pointing. Never mind. Sorry. Okay. All right. So, let's try an actual problem here. Okay. Question?
Are there any times when manipulate
Sometimes, yes. Not intensely, no. But there will be a little bit of manipulation involved, yes. So, let me show you what I mean by that. We'll continue on here and do some more problems. Okay. So, let's try another one. I'll kind of try and leave these handy to refer back to. Okay, something. Well, no, I want you guys to be able to see. Can you see okay back there? What I've got up here? Okay. I'll just do it this way then. All right. So let's just jump right in. Okay, so we'll say dx over 2 plus 9x squared. Integral of dx over, which is really 1 over 2 plus 9x squared. Okay. So, what are we thinking for our so again, I'm going to go ahead and just tell you it's inverse trig, right? I know in the wild you won't be told that it's inverse trig, so you need to figure that out. But which inverse trig function does it look like this matches up with? Arctangent. Very good. Okay, so we're going to go with the arctangent, which involves figuring out what our a and our u are. Okay, so which of these is a squared?
Right. It's over 2.
It's the 2. It's the 2. Which means then, which one of these is the u squared?
9x squared.
9x squared is the u squared. So this thing is a squared. So let's rewrite this then. Say again? How do we know? So a is always going to be our number. A squared. So 2 is the number there. So if this is a squared, what does that mean just plain old a is? Square root of 2. So we're going to rewrite this as square root of 2 quantity squared. Okay? Plus, and if this is our u squared, then what's plain u? What's just u? 3x. So we rewrite this in a more appropriate kind of format for how we want to integrate here. Okay. So if 3x is our u, that means we need to do a u substitution here. We're going to let u equal 3x. And so then du is what?
dx.
Careful.
3dx.
3dx. Okay, we don't have 3dx. All we have is just dx here. So what do you have to do to both sides? Divide by 3. So we get 1/3 du equals dx. And so I'm going to rewrite that 1/3 integral du over the square root of 2 squared, bless you, plus u squared. Okay, like that. Okay, now this is like the most amount of like kind of preparation work we do when it comes to an integral, but I think this will help us to then get this integral right, because it's easy to like miss some of the subtleties here if you don't take this extra careful time. All right. So now we're ready to go. We have our a. There's our a. There's our u, okay, being squared right there. And so we're going to have 1/3 times, okay, the integral of this is, the arctangent's integral is, it's 1 over a. So it's going to be 1/3 times 1 over what?
Root 2.
Root 2 times the arctangent
3x.
of u, I'm just going to write u for right now, over the square root of 2, plus c. Don't get the plus c at the end, right? Because this is not a definite integral, it's an indefinite integral. All right. And so we get then 1 over 3 root 2 arctangent, and u is 3x, so it's going to be 3x over root 2. Remember to sub back in for the u. Some of you guys on your homeworks last night when I was grading them, I saw you did not substitute back in for your u. And I know that you know that I know what you know, but you need to make sure you're practicing plugging back in for the u. So in calculus, you don't have to rationalize denominators. So this is sufficient. You may stop here. Okay? So that's it. And we can be done. We did it! Hooray! Okay, so let's try another one. Alright. 1 over x times the square root of 4x squared minus 9 dx. So instead of putting the dx on top, I just put it beside it. Okay, so which inverse trig function does it look like we're being set up for here? Yeah, the arc secant, or inverse, secant inverse, okay? So, let's manipulate this around. So again, you can look at the board there and see what we need. So let's kind of rewrite this a little bit here. So it's going to be integral 1 over, excuse me, x times the square root. So 4x quantity squared, that's just then 2x squared, right, like that. And then the minus 9 becomes minus 3, that quantity squared. Like so, right? Now, does anyone see a problem here? Say again? Two different u's, right? This, because this thing and this thing, this is supposed to be u, this is supposed to be u squared. But this is 2x and this is x. These two things are different. And so right now, as it's currently written, can we integrate this yet? Yeah, the answer is no, okay? We need to manipulate this somehow so that these two things match. So, this 2x is kind of inside of a square root and it's being squared. So we probably don't want to try and manipulate this, so we want to try and match this x to become 2x. So what do I need to do to this x to make it 2x? Multiply by 2. So okay, right, just multiply by 2.
Or multiply the top by 2 as well.
But right, we can't just like throw in a times 2 just because we feel like it. However, what we can do is multiply by 2 over 2, right? Because what's 2 over 2 equal to? 1. You can multiply anything by 1, it's still the same thing. And so now this becomes then the integral of 2 over 2x square root of the quantity 2x squared minus 3 squared. Okay, and then I'll put a little dx out there. Okay. So now we can finally do a u substitution here. We're going to let u equal what? Yeah, so I'm going to kind of scoot this over some more here. So let's let u equal 2x, and so then du equals what? 2 dx, which we have. Look at that. There it is. 2 dx. All right, so let's change it. So it's the integral then of du over 2x becomes u, square root of u squared minus 3 squared. Okay. All right, and do I have a volunteer that wants to then give me what's going to be the integral here? What will be the integral? We're ready to do it now, so what will the integral be? Brandon, go for it.
1 over 3.
1 over 3.
Oh my gosh.
Arc
Ryan.
Arcsecant.
the absolute value. You want it in terms of u right now?
Sure, yeah, let's do it in terms of u, thank you.
Well, I'll give you use over 3.
3
Plus
plus c, there you go, that's right, yep. Beautiful, there it is. Okay, 1/3 arcsecant, the absolute value of u over 3, plus c. And so let's plug back in for our u then, so it's 1/3 then arcsecant
Hey, buddy.
of absolute value of 2x all over 3 plus c, and there's our final answer. Okay?
Did you get a sheet? Trying to open them up. Okay, tell you.
Questions? Okay, we're good on that? All right, let's try another one. Let's do another. Again. All right, we're going to evaluate the integral of 2e to the x dx over the square root of 1 minus e to the 2x. Say again, sorry? Isn't it? Yes.
Is this stuff new? And
We're continuing the inverse trig integral stuff.
But is there like...
It's new.
New concept? No. I mean, it's the same idea. We're just practicing it. We're practicing. I just spit. Okay.
This is what I saw that. I didn't see that. I don't want to mention it.
I need to drink some water. Huh? My keyboard.
That happened.
Sorry, computer. Okay? What does it look like we might be using here? What inverse trig might this be?
I'm going to go with arcsine.
Okay, look, arcsine? Okay, what's getting in the way then? Probably arcsine. Why not arctangent?
Because there's no... Well, there's a square root under the fraction. And there's nothing in front of the square root.
Arctangent has no square root and it's addition. Okay, so if you have no square root and addition, arctangent. If you have square root, then you want to really look at the order of things. Arcsecant has something in front of the square root. Arcsine does not have something in front of the square root. Also, arcsine is a squared minus u squared, so it's number minus function. Arcsecant is function minus number. Okay, so that kind of helps figure that out.
Put it on my notes.
Just the way it has to be like that on that, and you have to like negative, plus.
Well, right, if it could be manipulated to be that then. Or like, yeah, rewritten. Okay, great. So, that being the case here then, let's rewrite this slightly. So let's see here, we've got 2e to the x dx. We still have this weird thing on top though, right? If you look up there, we're saying it's arc sine, but arc sine only has a du up there, so we better hope that our u substitution accounts for this.
Should we take that 2 out or no?
We can. I'm going to leave it in there for right now. So, e to the 2x is what squared?
E to the x squared.
Right, e to the 2x here, folks, is e to the x quantity squared, right? Remember, when you have a power raised to another power, you multiply the powers together. So e to the x to the 2 becomes e to the 2x. Okay? So, what's our u going to be here? Just e to the x. E to the x, that's right. Okay, it's this function right here. So let u equal e to the x. So then du is what? E to the x dx. We have e to the x dx, so yeah, this 2 then, we probably just want to pull this out front, right? We don't need the 2 there, it's a coefficient, so let's just pull that out front. So we'll make it 2 times the integral, okay, of du over, because again, e to the x dx is becoming du now, over the square root of 1 squared minus u squared. Oh, sorry, thank you. Is that good, James? Okay. Which then equals 2 times what? Let's go to... Oh, I better pick someone that's right there. Connor. So when I integrate this now, what's it going to become? 2 times what?
It'll be sine.
Arc sine. Yeah, be careful. Arc sine. Which is u over, what's the a in this case? 1. So it's u over 1. Plus c. And there it is. Okay? And so we can write that as then 2 arc sine of e to the x plus c. And there's your final answer. Okay? Easy peasy. Lemon squeezy.
Mac and cheese.
Mac and cheesy. All right. Questions on that?
Give me something that I don't have. I have mine.
All right, here we go. Evaluate. Let's try another one. Okay, so we got a definite integral now. Okay, we have a definite integral now. So it's x plus 4 all over the square root of 4 minus x squared.
That looks familiar.
Okay. So before you guys start writing here, let's think about this somewhat. So first of all, what inverse trig function does this look like it's going to be? Arc sine. Okay, good. Yeah, you see the 4 minus x squared there. Okay, now let's just kind of like think through this sum. So what's our a going to be? 2, right? Because this is a squared, so 4 will be 2 squared, so it's 2 is a. What's going to be our u here? X. So if we're going to let u equal x, if we let u equal x, what's our du going to be? Dx, right? We have a problem, though, because our numerator has an x in it. And so this du only accounts for the dx here. It does not account for x plus 4. So, we need to rewrite this sum. Okay, we have to manipulate this sum. So just like, sometimes we have to rewrite integrals so we can integrate them, this one is no exception here. We have to be able to rewrite this one. Now, obviously, this one is probably like one of the more probably one of the most difficult ones to see because we just learned inverse trig, and it's like, still kind of unfamiliar to us, and now on top of that we have to, change things around. So this is like probably at the highest level of difficulty for us right now, okay, that we can do. So break this up over addition, right? I don't think I left myself enough space. How are we going to integrate this one?
That one's fine. Oh, no, never mind. I was thinking.
What's this going to be? It's going to be a u substitution. That's it. Let u equal what? 4 minus x squared. Yeah. This one is a straight up u substitution. We could do this one before yesterday, okay, before we talked about inverse trig integrals. What's this one going to become?
The arc sine.
This is arc sine, okay? Look at this, guys. I don't know if you can, maybe we can appreciate this, but I mean, maybe you don't care, but the only difference between these two integrals is that this one has an x and this one's a number. This one is going to be a basic u substitution where we end up, getting some sort of like u to the 1/2. This one becomes suddenly arc sine. All right, so there's like just slight changes in the function result in way big changes than in their integrals. Okay, slight changes, subtle changes in the function result in very different integrals. Okay, so let's do this one first. All right, Emma's correct. We're going to let u equal 4 minus x squared, and so then du is equal to negative 2x dx. And then we have some further manipulation here, right? Because we don't have negative 2x dx, we just have x dx. So we'll divide both sides by negative 2, so we get negative 1/2. Du equals x dx. So I'm going to have to like leave myself some space over here. So this first integrand is going to integrate, and put a negative 1/2 in front of that. Ooh, barely fit it there, okay. Du over u, square root of u. Okay. Why didn't I write my limits of integration here? It's in terms of u. These limits of integration were limits of integration for what variable? X. I wrote it in terms of u now, so it's no longer valid to use the 0 and the 1 there. You can change them if you wanted to. You can put the 0 in, the lower limit would be 4, put the 1 in, and the upper limit would be 3. You can do that, but I'm going to just leave it like this for now. Yeah.
What would happen if we had like the first one, our u was x, and then du is equal to dx? How would that change the, would it just make the limits of integration the same?
Yeah. So, but we're not going to use. We're not using that one. But yes, exactly. The limits of integration stay the same in that case. Okay. Anyway, and then moving. So again, that's a negative 1/2 in front of that integral, and then we're going to try and integrate this. So let's see. I got to rewrite some things. So it's plus. So the 4. Let's pull that 4 out front for this second integrand here. Okay. And so we end up with 1 over the square root of 2 squared minus x quantity squared there, dx. That is weird. Okay. This we need to rewrite some too, don't we? This first integrand, how should we rewrite this? Not 1 over the square root of u, but how should we rewrite it? U to the what? Negative 1/2. Yeah, you want to rewrite it using a single exponent there. That square root symbol is not helpful to us when we go to integrate stuff. This we can actually integrate as it is, since it's just plain old x being squared here. I mean, we could like do another u substitution, but since it's just x being squared, we can actually integrate it right now. Okay, we're ready to do that. So it's going to be 4 times, and so again, this is arc sine, right? So it's going to be arc sine. There's no 1 over a in front of the arc sine, so it's arc sine of x over 2. Okay, like that. And we can put the plus c in. Yeah, we should put the plus c in for right now, yeah. Okay. And then we'll integrate over here. integral of u to the negative 1/2, u to the 1/2, right? And then times, 2, and then times negative 1/2. We brought down the negative 1/2, and then when you increase the power by 1, it becomes positive 1/2, and you divide that power out front. So 1 divided by 1/2 becomes 2. I did not leave myself much room, but I think I'll be okay. Question?
Yeah, so when you do arc or inverse trig,
Mhm.
so it doesn't matter if it's a definite integral or because you just...
We're going to evaluate that at the end here. Once I finish getting through everything back in terms of x, then we're going to evaluate the whole thing. Yeah, because, we definitely want to still evaluate those limits. You're right. Negative 1/2 times 2 is negative 1, so we'll just leave it as negative. And then u to the 1/2, well, that's now 4 minus x squared to the 1/2. Plus 4 arc sine of x over 2 plus c. And now we can finally evaluate that back, because everything's back in terms of x from 0 to 1. Woohoo! Like I said, this is like the most difficult problem you guys I would even ever ask you to attempt. I would not go any harder than this for sure, but you will not get something this crazy on the test, okay?
So when we're asked to evaluate like arc sine, are we expected to know what those values for that are?
Yeah, we'll talk about evaluating arc sine here in a second, yep. You need to know the integral rules, yeah. With emphasis on tangent first, then arc sine, and then RC. Okay? But if it's a non-calculator section, you're screwed.
I forget about that. Hey.
All right, so we're going to continue on here. So now we're going to finally plug in. In fact, I'm going to rewrite it over here just so I can give myself some space, because this is just a little ridiculous now. So negative 4 minus x to the 1/2 plus 4. Okay, evaluate that from 0 to 1. Okay, here we go. So let's plug in the 1, upper limit first. So 4 minus 1 to the 1/2 plus 4 arc sine of 1/2. That upper limit, there's the upper limit plugged in, minus the lower limit. Sorry. There you go. So there it is plugged in. Okay. Yep. This on a free response question, you're done. The step up here. It depends on the way that the problem is scored. Okay, but once if you get to here, Anna, then this really is not that hard, right? It's writing this thing twice and just plugging 1 in instead for the x and 0 into the x. That's it. If you can get to this point, Anna, you can do this. Okay. All right. Let's simplify a little bit more here. 4 minus 1 is 3. 3 to the 1/2, it's not really, so we'll just leave it as the square root of 3. So it'll be negative root 3. Okay, now here we go. Arc sine of 1/2. Boy, if we think we're bad at trig, I'm sure inverse trig is even less comfortable for us, right? Or if trig is uncomfortable for us sometimes, inverse trig is even less comfortable, okay? The idea is this, though. Inverse trig, actually, let me start back. Trig is when you take sine of an angle, cosine of an angle, tangent of an angle, and then you get out of that a fraction or a ratio. Yeah, guys, can we stop playing with the paper, please? Thank you. I'm paying attention up here, okay? So if you plug in an angle to a trig function, it spits out a ratio, like 1/2, root 3 over 2, all those things that we know from, unit circle and stuff like that. For inverse trig, it's the inverse, the opposite of that. So you plug in a ratio, it spits out the angle that makes it. So arc sine of 1/2 really is saying sine of what angle gives you 1/2. So sine of what gives you 1/2? It's pi over 6. Yeah. So plus 4 times pi over 6. okay? Minus, and let's see, it's 4 minus 0, so it's going to be negative 4. And then arc sine of 0, okay? So again, sine of what gives you 0?
Should be negative root 4.
We'll give you, there's two options.
Oh, sorry, thank you. Negative square root of 4. So I'm just going to leave it like that because I don't want to have to rewrite over my stuff. So yeah, well, I will. Yeah.
No, wait, arc sine of intervals involved with it, so that'll just be negative. That'll just be 0.
It will be 0, exactly right. So it's 0 times 4, so it's just going to be plus 4 times 0. I'll go ahead and just do this simple. What's that?
Arc sine is like negative root 2 over 2 over 2, right?
Yeah, it's negative root 2 over 2 to root 2 over... Oh, sorry. Negative pi over 2 to pi over 2.
Yeah, my bad.
It's from the fourth quadrant up to the first quadrant. Fourth quadrant up to the first quadrant. Okay, and then cosine and tangent are both first and second quadrant, so from 0 to pi. All right. Anywho, finishing this off here, we get negative root 3 plus 2 pi over 3. 4 to the 1/2 is 2, but it's negative 2, but it's minus negative 2, so it becomes plus 2. And then 4 times 0 is 0. So there's your final answer. Negative root 3 plus 2 pi over 3 plus 2. I do not give you something this messy on the test. Okay, I'll tell you right now. You don't get something this nasty on the test. Because that would take forever, first of all. It would just take forever. I mean, that problem took a while, right? Half an hour later, there it is. All right. So let me review it real quick just to see, because I'm going to ask, I'll ask, are there any questions? And everyone's going to be like, yeah, to everything. And then, so that won't really be helpful. So let me just kind of go back through it. All right. We came across this problem, okay? It's in inverse trig, so we know we should do some inverse trig here, right? There's got to be some inverse trig. But as it's currently written, it does not straight up inverse trig, right? If we let u equal our x here, then du would just be dx, and that's not what we have in our numerator. So we can't straight up just say this whole thing is going to be an arc sine. It's not. So we had to break it up using what we know about integrals, right? You can break up an integral over addition. X over the square root of x 4 minus x squared plus 4 over that. This is a simple u substitution. Well, not simple. It's a u substitution. This is arc sine, and so we had to do two different integrals there, two different amounts of work. We integrate, we evaluate, and we end up simplifying down to there. Okay? So that's the summary. Let's try another one here. I think I've got a few more. Yes. Okay. So we'll do two more, and then we might just do one more. We'll see.
And then tomorrow and Thursday are devoted to review.
Yeah. All right, one more here. Evaluate the integral dx over x squared minus 4x plus 7. So if you ran across this problem in the wild, like if I didn't already prompt you with the idea that we're using inverse trig here, and you looked at this, what would probably be the first thing that you try here?
Making a negative exponent, but I know that wouldn't work.
Negative, yeah, no, x squared minus 4x plus 7 to the negative 1, yeah, that wouldn't work. No, what else might we try? Factoring it? Does it factor? Yeah, no, it doesn't factor. No. What else might we try? Move on to the next problem. No. What's that? Okay, u substitution. You would let u equal what in this case? The denominator, x squared minus 4x plus 7, okay? But then you end up with the du being 2x minus 4, and you don't have 2x minus 4 in the numerator there. So that doesn't work either, right? So it's like, well, now we're out of options here. But believe it or not, this is an inverse trig problem. So not quadratic formula.
Division.
Complete the square, as we're going to do here. Oh, yeah, complete the square. Everyone loves it. You know you love it. Okay, so I'm going to show you here real quick, all right? So this does not factor at all, right? Now, there are some quadratics that we call perfect square quadratics. For example, x squared plus 2x plus 1 is a perfect square. Why? Because when you factor it, what do you get?
You get x plus 1 squared.
not nice numbers, x plus 1 times x plus 1, which is then just really the quantity x plus 1 squared. Okay, so this is a perfect square quadratic because it's the product of two of the same binomials, x plus 1 times x plus 1, x plus 1 quantity squared. This doesn't even factor, let alone it's not a perfect square. Okay, so what makes a perfect square quadratic a perfect square quadratic? Okay, so for example, x plus 2 quantity squared, what's that going to be? What's that quadratic going to be? Well, it would be x squared plus 4x plus 4. All right, let's look at x plus 3 quantity squared. What would that be? X squared plus 6x plus 9. So, what's the pattern here? The middle term,
Is the sum of the two.
if you take half of that, right, because it's going to be like, because both these numbers are going to be the same, so if you take half of that, okay, then you get what these numbers are going to be, and you square it, you get this number. So it's like half the middle term and square it, 4. Half the middle term and square it, 9. Okay, that's how we kind of get to completing the square. So here, for our pattern, all right, half middle term here is what? Negative 2. Squared is 4. So we need this to be a plus 4, but it's currently a plus 7. But I can do this. Right? Isn't that the same thing? It's a different way of doing it. It's a different way of doing it. Because when you did it last year, you had equations, so you had to like add something to both sides. Here it's not an equation, so we have to kind of keep it within the problem itself. Did I change the value of my integral at all here? No, still the same thing, but I manipulated it because now, how does this thing factor? X minus 2, quantity squared, plus 3. And now what inverse trig does it look like it's going to be? Arctangent. Yes. We're going to let u equal what? X minus 2. The quantity, because remember it's u is being squared, so we want the quantity x minus 2. So then du is what?
du is dx.
1 dx. 1 dx, that's right. And so this thing becomes then the integral of du over u squared plus, we should probably manipulate this 3. 3 is also a perfect square of square root of 3, right? So our 3 here is really square root of 3 quantity squared. Right? Because this is a squared, right? It's plus a squared. It's u squared plus, well, it's a squared plus u squared, but we have to flip it around. It's u squared plus a squared, so then we need the a. The a is really square root of 3. That's the a. Okay, that's a. And so then, let's go to... Oh, Brandon, we already heard from you. So Maya, can you give us what the answer is going to be here then, from the way it's written?
So
1 over root 3. Great.
arctangent of u over
Uh-huh. Good. Even, let's see. Good job. Exactly right. And then, of course, we plug back in for the u. So it's 1 over square root of 3 arctangent of x minus 2 over the square root of 3 plus c. And there it is. Okay? So again, that's a difficult one, right? How would I ever expect you to remember that? But there it is. You've seen it now. Not that I'm saying you're gonna see it again on the test, but I mean, that's a strategy we can use there.